Alright, this is the second video for March, I believe 10th. That sounds right. We'll go with that. March 10th. Here we're looking at the asymptotes of functions and see how they dictate how our functions should be graphed. Here, excuse me. Here I already looked at, I wrote this in standard form, SF. Notice that the degree in our denominator was bigger than that of our numerator. Here we're talking about a degree of 2, here degree of 1, which led to a horizontal asymptote at y equals 0 because our degree in our denominator was bigger. We can factor our denominator. Here x squared minus 1 is a difference of 2 squares, and so we know we have vertical asymptotes because nothing cancels here at 1 and negative 1. This one can get a little tricky, and I'll walk through it. If you need more clarification on the asymptotes, pause it, rewind, all that stuff. I'm going to keep going here. 1, 2, 3, 4, 5. We have two vertical asymptotes here, one at 1 and one at negative 1. So the one at 1 would be here, negative 1. And we have a horizontal asymptote y equals 0. Where does y equal 0? On the entire x-axis. So we have, I'm just going to kind of draw it up a little bit so we can see it, a horizontal asymptote there. So that takes care of our asymptotes. Oof, gosh. Now we're set up to graph the function. But in previous functions we only had 2 sections. Here we have 3 sections. So we really have to be careful in terms of what's happening in each part of our function, each third, if you will. So let's start with the outside pieces. Here we plug in a value. Here we have an asymptote at 1. Let's go 1 to the right maybe. That works. We can plug in 2, 3, 4, 5, anything to the right. Anything to the right of this asymptote we can plug in. I'm just going to choose 2. And if we do that, we would end up with 5 over 3 or 1.67. So f of 2, if we plug in 2 into our function, we get 1.67. So that means at 2, the value would be 1.67. And because we have this like L-shaped asymptotic behavior, if you will, this is what our function would look like there. We can do a similar thing to the left. Here, let's say we want to plug in negative 2. Just trying to figure out how we want to do this. And if we do that, we would end up with negative 3 over 3 or negative 1. Which means the function's value at negative 2, negative 2 here, would be negative 1. So this function goes something like this. Now, what is happening in the middle here? That is the question. And we don't quite know. It could take a lot of different shapes in the middle. But we can figure out. What we have to do, I highly recommend, anytime you have a middle section, is to plug in multiple values, 3 values. I think a 3-value minimum. And some people say, well, we can only plug in 1. We can only plug in 0 because that's only 1 here. No, we can also plug in 1/2 and negative 1/2. So I'm going to let you try that on your own, plugging in 1/2 and negative 1/2 into the function. I'm about to give that, but if you want to pause it, that's fine. If you plugged in 0, what you would end up with is negative 2. Oh, I lied. Negative 1. If you plugged in 0.5, positive 0.5, you would end up with 0.67, and if you plugged in negative 0.5, you would end up with negative 0.67. Is that right? Let me just double check. You would end up with 0, actually. No, you wouldn't. Give me a second here. Man, struggling, long day. 0.5, what you would end up with is 2 over negative 0.67 and negative 0.67. And positive 5 over 8, so 2.67. Something like that. Essentially what's happening here at 0.5 is going to be negative 0.67, so it's going to be hitting here. At 0, it's at negative 1. And then we can graph the other piece. Excuse me. Let me just check something real quick. I'm doing mental math, but it's been a long day, so that's scary. Okay. So this actually goes, the 1/2 goes through negative, this is right, the negative 2.67. This should be negative 2.67, the negative 0.5, my apologies. The negative 0.5 should be 0, or pretty close to it. Yep. 0. So this looks like, my apologies. So essentially what's happening here, h of 0 is equal to negative 1. Ignore all this. Man, that's a mess, isn't it? Hey! What am I speaking Spanish? Negative 2.67 and h of negative 0.5 is 0. All right, that feels a lot better. Now what we can do is draw the curve that goes through those 3 points. Ignore that one. That's a terrible mistake. And that's what this function looks like. All right. So anytime you have a middle section, I highly recommend graphing three points. Also, I highly recommend using Desmos to make sure that you can graph that correctly. I have one more video to do the last one with a slant asymptote, see how we can graph that, and then I'll stop.